So it's my very great pleasure to introduce our three guest speakers. Associate Professor Phil Gregory, who's the head of the gene regulation in cancer at the Cancer Lab at the Centre for Cancer Biology. You saw Natasha Harvey speaking before. We've been funding, come on up Phil, we've been funding Phil for a few years now, both in prostate and breast cancer, so looking forward to hearing about your progress today, Phil. Thank you. With us today is a very special person, Dr. Kathy Short, who's the clinical lead in Central Adelaide Local Health Network's Neurology Memory Service. Finding a cure for dementia would be the holy grail of research. And Kathy is supervising some really interesting clinical trials at the QEH, and so we're looking forward to hear that. And Maddie Bills, who's not just a clinical project manager at the Central Adelaide Local Health Network, but also is a qualified nuclear medicine technologist in her own right. She's working on a really interesting project only at the Royal Adelaide? Yeah, at the Royal Adelaide Hospital, and it's leading to improved hospital efficiency and waiting time. So please again welcome our guests. So welcome. Phil, can you just give us a quick synopsis of what you do and focus just on work, would you?
Work?
Yeah,
Yes.
work, yeah.
I can focus on work. So as Paul introduced, I run a research lab at a place called the Centre for Cancer Biology, and so everyone within my institute focuses on cancer biology. And my lab in particular, we're really interested in breast and prostate cancers. They're two of the most diagnosed cancers. I'm sure everyone in the room has probably had someone they know or perhaps have experienced these cancers themselves. They can be really debilitating. One of the things that links the two cancers is they're both hormone driven, and a lot of the therapies rely on blocking the hormones. This treatment is actually quite effective, but one thing that's come to light is that there's a lot of resistance that develops to these treatments, and so we're very much interested in understanding how the resistance develops, how the cancer cells become aggressive and spread, and ultimately we want to try and come up with better ways of tackling these diseases.
Thanks. And Kathy, can you give us a bit of a summary of the research project or the clinical trials you're working on? We'll go into some specifics a bit later.
Yeah. So I do a range of clinical trials. I'm a neurologist, predominantly based at the Queen Elizabeth Cognitive Neurology Service. So we're part of the Department of Neurology, which is across Royal Adelaide and Queen Liz. And our memory trials / memory service has been in operation since the late 90s. And we began doing trials in the very first symptomatic therapies that we still use today for Alzheimer's disease back then, and we've evolved over that time. We've been doing research for a very long time now, and the current trials are predominantly in Alzheimer's disease treatment, and one of the big focuses at the moment is removing amyloid. So amyloid's one of the main abnormal proteins that's deposited in the brains of people with Alzheimer's disease, and we've been doing trials on anti-amyloid antibodies for some years. We've had a lot of negative trials, but just in the last couple of years we've had some success, and in fact there's been an anti-amyloid agent being TGA approved in May of this year. So we're continuing to do work in that area, predominantly Alzheimer's disease. We have done some frontotemporal dementia studies as well, but predominantly Alzheimer's, and early Alzheimer's is our focus.
Thanks, Kathy. We'll drill down a little bit into those biomarkers in a few minutes. And Maddie, can you? I mean, I know that your training was in a different area, but you've really made yourself irreplaceable, really. And I know that we're funding the project that you work on. Do you want to briefly talk about that?
So I'm here today in my capacity in health services research. So what we are doing in this project at the moment at the Royal Adelaide is trying to look at a new way to understand hospital demand and performance. So what that really means is that the data that's really used to map and plan in the hospital is retrospective. So we normally only understand about the demand and the complexity of the patients that we've treated about 3 months after they go home. So what we're trying to do in this project is use markers in the electronic medical record that tell us about the types of care that patients are receiving while they're actually in the hospital during their stay, so that we can proactively allocate resources and improve flow across the hospital.
Yeah, thanks, Maddie. I'll stay with you because this is, I think everyone in the room would probably, if not is fascinated, should be fascinated because, all of the media you hear is ramping, okay? And the end result of some of the work that you're doing is how do we get people to the place they need to be treated in a timely manner, and then how do we get people out of hospital?
Yeah, we're starting to come across some recommendations. I guess the 17.5% I was going to round up a little bit for make it a bit easier today. But we've got about 80% of patients who come to the hospital. We can really understand the care and the resources that they're going to use within the first 24 to 48 hours of their admission. So that 17.5% is this really complex group who have lots of teams looking after them. They need lots of medications, they're having lots of scans, lots of blood tests and those sorts of things. But their care doesn't really follow a straightforward trajectory like the other 80% of patients. So what we're sort of doing in this group of patients now is bringing in AI and machine learning to sort of try to find some patterns in this group so that we can sort of better understand what it is that these patients need, and then that then feeds into improving flow and reallocating resources across the organisation to help everyone.
Kathy, to try and break it down to layman's terms, right? let's quick give everyone, not when I say let's, I'm not including you and I. Between you and I, we're great neurologists. But let's explain to people what a biomarker is, and you've already talked about amyloid and why biomarkers are important in that early detection.
So biomarkers is basically another way of helping us to diagnose a disease. So up until very recently, the diagnosis of dementia has been predominantly a clinical one. So we would rely on neuroimaging, so MRI scans, etc., and cognitive assessments. And still then, our accuracy of diagnosis was around about 70 to 80%. So the advent of biomarkers, there are two ways that we can look at Alzheimer's disease biomarkers now. One is looking at cerebrospinal fluid via a lumbar puncture. We can take some samples of fluid off, send it to the laboratory, and they will pick up the amount of amyloid and tau, which are the abnormal proteins in Alzheimer's disease. And the other way that we can assess Alzheimer's disease biomarkers is through an amyloid PET scan. So a PET scan is a bit like a CAT scan, but you'll have an injection of a radioactive material that binds to amyloid, and then it shows up on the scan and tells us whether or not you have amyloid in your brain. So they're really the two main ways that we can look at biomarkers at the moment, and there is also in development blood-based biomarkers, which are predominantly still in research settings at the moment, but will probably become more mainstream over the next year or so.
Okay. So when I first met you recently, I think I've mentioned this to you, but I've definitely mentioned this to you before, but we had three of the most accomplished neurologists in South Australia in our office, and they were like excited children because they've identified not just a potential clinical trial, a drug for clinical trial, but someone that we wanted to bring back to South Australia to do it. Do you want to talk a little bit more about that clinical trial, or any clinical trials that you're doing?
Yeah. So.
Or maybe you don't want to talk.
So the reason we came to visit you was because we were very keen to get a brilliant young researcher back home to Adelaide who'd spent the last couple of years in the UK working in their dementia research centre over there. And apart from wanting to have him back because he's, you know, very, very good at what he does, we also had wanted him to help us develop a service to deliver these new medications, which are infusions. So generally either fortnightly or monthly infusions of these anti-amyloid treatments. So he's been helping us develop that service, and we're getting very, very close. His 2 years will be up in March of next year, and hopefully after his research funding from you guys runs out, we'll be able to employ him through the hospital service. So that's what we're developing at the moment with his help.
So this is where we talk about give while you live, gift in wills.
That's right. That's right. Yeah.
So Phil, we know you work across those hormone-based cancers, prostate cancer, breast cancer, but you've been doing some specific work in triple-negative breast cancer. Please nod. Yes, good. You have. Otherwise, they gave me the wrong Phil. Do you want to talk a little bit more about, well, first of all, what's triple-negative breast cancer? There'll be some people in the room that would know, but most people won't, and the work you're doing.
Yeah, absolutely. So triple-negative breast cancer is a type of cancer which women that get breast cancer, probably 10 to 20% of them would have this triple-negative subtype. And what the pathologists do is they they look for these biomarkers, and they're essentially receptors that are on the surface of the cell, and 2 of those are hormone receptors. But if all 3 of these are negative, the breast cancer is classified as triple negative. And one of the consequences of that is that these hormonal therapies are no longer available to these women because they're not going to work, because they don't have the receptor for the hormones. And
so just explain what that means. I mean, people hear receptor, but in layman's terms, the treatment has to be able to latch onto something. Is that right?
Yeah, that's right. So the receptor is this molecule on the outside of the cell, and that's actually the molecule that senses the hormone that's in the environment. And so if the breast cancer doesn't have that molecule on the outside of the cell, it's not going to sense the hormone and not going to be responsive to any anti-hormone therapies. So that's how it works. And then with triple-negative breast cancers, because there's no hormonal therapies, really the only option is chemotherapy. And if there's anyone that's had chemotherapy, I know there's probably some in the room. It's a pretty nasty thing to have. It can be very effective, but there are a lot of side effects, and so it's not a desirable option. And the other thing with triple-negative breast cancers is that they tend to spread more readily than other breast cancers. And so once they spread, that leads to other complications, particularly if it spreads to organs like the bone. You can get degeneration of the bone. And so it's not a very good situation. Chemo is really the only option, and so our research is really focused on trying to understand this cancer better and come up with better treatments.
So I just might move on to alternative funding. So one of the things the Hospital Research Foundation tries to do is help researchers with their research to a point where they can attract much bigger levels of funding, the sort of levels of funding that can help you push through to an outcome that could be translatable. And so how can I know you're not an expert on federal government funding, but that's the holy grail, isn't it? Either National Health and Medical Research Council, MRF, Medical Research Future Fund, Australian Research Council. That's the holy grail. And why is that the holy grail? And how has our funding, funded by these very generous people, helped you get there?
Yeah, so as you were suggesting, Paul, federal funding from these organisations is really important because it's can be quite a substantial amount of money, and it goes over several years. So it enables you to sort of take up a whole program of research, employ researchers for a longer period of time, so they can get acclimatised and really, over a longer period of time, make a big difference in the area that they're working in. And so the Hospital Research Foundation I think it was back in 2018 when I was just starting out my lab, and I approached Paul and said we had this really good idea in the prostate cancer space, and we're sort of looking for some funding to get it sort of off the ground. And Paul and the team at the time were just super generous, sort of a starting out person like myself, investing in that research. And then within a year, we found that we had some really amazing findings, and then applied for this federal funding from the NHMRC. And we're able to get that grant, and that grant actually was a collaboration between several centres across Australia. And now we've really progressed that research, including actually some researchers in Canada. And we've just had some really stunning findings, and now we're trying to figure out the best way to be able to translate those findings into practice.
Which is the grail, isn't it? It's the holy grail. So, Maddie, we talked a little bit about AI before and machine learning. And as I alluded to before, a lot of people in the audience probably hear the scary things about AI, and you have to be careful, and you have to be strict with how you use it. But there's some great opportunities in health to use AI and machine learning, and I'm an unashamed fan. I use AI and practice using it, and it's made huge efficiencies in my day. My jokes were written by AI today. Yeah. Even that joke was written by AI, right? But Maddie, from your perspective, I'm not asking you to be a futurist, but it's helping what you do, and do you see a big future for it in the provision of healthcare?
Yeah, definitely. And I think, along with everyone, I used to find AI pretty scary too before I started in this project, and sort of really started to understand how it actually works. And I guess if we strip it back, for something to make it a little bit more boring, it really is just maths and statistics. It's finding patterns for us that we can actually make something actionable out of. We have been listening to our patients about using their data with AI in healthcare. We've held quite a number of focus groups with patients from the organisation across lots of different professions as well, just trying to understand people's perspectives of using AI, and I guess trying to understand how well this would be adopted across the healthcare system. What we really heard quite strongly was that patients are comfortable with us using their data with AI, as long as we are really transparent about how we're using it and why we're using it, and that we've got the safety measures in place, because that's a really big piece of the puzzle. And I guess, AI in healthcare really is deemed to be a bit of a high-risk area, and I think it's really important to highlight that data being used with AI in healthcare is never going to be left on its own. It's never going to be replacing clinicians. It's always going to have a human in the loop, and I think it's really important that people sort of know that that's how it's really a tool to help. It's not to replace. But I guess in terms of the applications that we're sort of seeing to come out now, in the hospital, there's tools that predict when patients are going to be ready to be discharged, or things like predicting patients' outcomes after surgery. We're seeing things like AI scribes, where the AI is actually recording and taking the notes for the doctor while they're talking to their patients, so the doctor can spend more time with the patient rather than doing the documentation. We're seeing models being created in terms of trying to train our junior medical workforce, where the AI robot is actually the patient, and it's sort of teaching the doctors how to diagnose patients. And then there's also the flip of this, where we're sort of seeing how accurately can AI diagnose patients, and then the AI robot is interviewing the patient. And my favourite part from this finding was that the patients actually rated the AI robot more empathetic than the actual doctor who just interviewed them. So that's something for us to be a little bit nervous about in health, I think.
Well, when people come into my office, I said, you've got a choice. You can talk to me, you can talk to the scribe. Which one do you want? They always pick the scribe.
But yeah, I think it's a really exciting time in health, but I think we just need to be aware of how we keep patients' data safe. And I think, there's lots of guardrails and policies being put in place to make sure that this is taken really seriously.
But Kathy, can you, from your perspective, how do you think this might roll out in the next, and I think in AI we're talking 3 months, 6 months, 12 months. It's too hard to look too far forward.
Yeah, I haven't had a lot of experience with AI, but I know that one of the nurses in our department is involved in a project where we're using AI to record the dialogue in a patient interview. And I mean, I think the other thing that that Maddie has mentioned is in terms of diagnosis. You know, dementia has always been a very difficult diagnosis to make, and although we're getting there, we're getting more accurate. I imagine that AI will have a role in, you know, recognising the patterns, putting all of the data together, and coming up with the most likely diagnosis. Radiology. I think it's going to become more important in radiology, neuroimaging, particularly in my area. And then I think in terms of dementia patients and carers themselves, you know, there are things around like companion avatars and environmental sensors that can be installed in homes, and smart environments that are going to help, you know, look after patients longer in their own home.
So Phil, what about in your area?
Yeah, we use AI very regularly. Probably most people in the lab would use it on a daily basis to help with writing. Maybe many of you have done that. Sometimes it throws a few curveballs and tells you the wrong thing and you have to correct it, but it can be very useful for that. And we found it's very useful for integrating lots of complex data and telling you about patterns. As mentioned before by Maddie, that's what AI is really good at, is numbers and statistics. So crunching data and telling you, you know, what you might be able to see in the data that a human might not be able to easily come up with. So I think I can see, particularly with all the genomic type data that's being generated now, there'll be a huge need for AI to deconvolute and make sense of all of that.
So Maddie, clearly in the project you're doing at the moment, collaboration, you know, you're herding cats, really, aren't you, across the hospital? You're trying to get people that may or may not see the benefit now of what you're doing, and you're trying to get them to come on the journey with you. So how's that been, cat herder?
Yeah, we've had some wins and some losses in that space, but it has been a really big piece of this project, and I guess we've only sort of made it as far as we have because we have been really invested in bringing people along on the journey with us. So we regularly are working with the doctors, the nurses, the allied health team. You know, we've also got the policy experts involved, we've got the data scientists, and we've got the hospital executives. So it's a very diverse group that we're trying to bring along on this journey with us. The way that we're sort of doing this is we're creating like different working groups, and these working groups are made up of representatives sort of from all of those parts of the organisation, and it's really about bringing together everyone's different perspective. So everyone sees the issue that we have in a different way, and it's really beneficial to just have us all in the one room, bounce the ideas around together. How does this impact from your discipline? What does this look like? And then how do we take this information and use it to move the project forward? Yeah, I guess that's kind of, you know, we've created some, you know, some really formal reporting mechanisms as well up into hospital executive, but, you know, the most of the work that is done is with the clinicians in terms of trying to understand how do we understand your data in the EMR and how does this actually reflect patient care.
Just tell everyone we're an acronym-free zone.
Electronic medical record.
And the Health Minister, Chris Picton, told me the other day that they're hoping to be able to roll out either late this year or early next year, a scribe across the whole EMR, a scribe tool, which would be
very, very helpful.
Yeah. So, Phil, sort of indulge me a little bit here, because I know you work in the prostate cancer space, and you know, I think I've mentioned before that I had prostate cancer and treatment, and I thought I'd get you to talk about what's next in prostate cancer. But you know, from your perspective, and I know you sort of keep a close eye on what's happening in the prostate cancer space. We have just told SA Peacock, the South Australian Prostate Cancer Registry, that we're extending and increasing their funding. But what do you see as the things that are most topical in the publications?
Yeah, it's actually Maddie and I were having a bit of a chat about it over lunch, and one of the new areas of these, I guess, theranostic. That's a technical word. It's basically a radiopharmaceutical, where you can essentially target radiation specifically to prostate cancer cells. And so this particular one called lutetium PSMA is a really hot area now, and people are they've used it sort of for very late stage disease at the moment, and it's proven to be quite effective. And now they're moving that slowly into earlier stage disease. And as Maddie was actually telling me, there's actually quite a few clinical trials, primarily based in Australia, using this drug. So that's one particular area which is gaining a lot of traction. And I suppose the other ones, there's always new generations of hormonal therapies, and they're being slowly moved again from later stage to earlier stage disease to try and sort of knock the disease on its head at an early stage before it progresses. And I guess the other area is immunotherapies, which you might have heard of. So using the patient's immune system itself to attack the cancer cells. And so that's a really active research space.
Yeah, and as I say, in talking to a couple of people in the medical profession, it's not timing, it's time in. It's, these things are coming up every day, so it's exciting. So apart from the really exciting clinical trials, Kathy, do you want to talk a little bit more about the actual memory trials unit and some of the things that that some of your patients can expect when they come to your unit?
Yeah, so our unit is, I guess it's a collaboration between memory trials and a diagnostic memory outpatient service. So if you have concerns about your memory and you're worried about a diagnosis of dementia, you would come and see us. And we work in parallel with the memory trials unit. So I think it's a really great relationship that we have, because currently, or up until very recently, the treatments that we had for Alzheimer's disease have only been symptomatic and modest at best. And so the opportunity to give people additional hope and refer them into clinical drug trials, I think is a really great thing that we can offer. So yeah, predominantly we're a diagnostic service with clinical trials attached, and as part of that diagnostic service, we have a fairly comprehensive workup process for diagnosing our patients, and we provide a detailed feedback appointment as well to all of our patients and ensure that they understand what their diagnosis is, and we link them into the appropriate community services, including Dementia Australia. And we also talk to our patients about the range of non-pharmacological strategies that are going to be helpful for their brain health and to try and help slow down the progression of their dementia.
All right, and to finish, because there's no such thing as a free lunch, what would you like to say, Maddie, to our lovely supporters here, and then Kathy and then Phil, about how the Hospital Research Foundation can help you do what you do, and how they can help us do what we give to you?
I guess we would really like to say thank you for your generosity, for all of your donations and the ongoing support of the Hospital Research Foundation in supporting our project to move forward. I guess health services research isn't a really well-known about domain of research, but it's actually a really important domain. It's about how we improve our health system. It's about how we innovate, how we fix the hospital system as much as we can. I guess it's really about bringing the awareness that this type of research isn't an optional extra. It's really mandatory to how we move the health system forward. So your support means that we can, dedicate people and resources and time to actually be able to do these functions in the hospital, and where we're all really working to improve patient outcomes.
Kathy?
Very, very grateful to the Hospital Research Foundation for providing us with a Dementia Research Fellow, which has allowed us to develop South Australia's first Alzheimer's disease treatment service with the advent of the new monoclonal antibodies. So all of your donations are incredibly impactful and helpful for all of us, so extremely grateful.
Yeah, I just shout out to Robin. Robin, who I sat with today, she donated personally some of the money that's gone to our research, and it's just made a huge difference. So thank you for that, Robin. But in general, I think the Hospital Research Foundation do an amazing job of really filling the gap. It's difficult to do research, it's difficult to get funding, but the Hospital Research Foundation really provide that sort of seed funding that's just so required to be able to get projects off the ground, to then progress them into the future. And for the workforce that do research as well, I think a lot of them might not be here without the Hospital Research Foundation funding. So yeah, just continue to support them in whatever way you do. What was the phrase? Where there's a will, you want to be in it. I think it's wonderful that you're all here. You're obviously very keen to support research, and I just say thank you for doing so.